Dear students, in this video we are going to see point representation of complex numbers in chapter 1. Usually we say that this. Now here when we plot the complex numbers, we used to say this is real axis, this is imaginary axis. Now we see how to graph 2 plus 5i. Now here 2 is the real part of the complex number, 5 is the imaginary part of the complex number. Now you have to count 2 units distance from the origin in the real axis. Now 1, 2. So here 2. Because this is real axis, this is imaginary axis. So now what is imaginary part? 5. So you count 1, 2, 3, 4, 5 units from the origin in the imaginary axis. Now this is 5. So now point of intersection is this place. So now this is called 2 plus 5i. So now what is this? Graph of 2 plus 5i is nothing but we can say that this is the complex number represented by the point 2 comma 5, or we can say that this is the vector from the origin to this point. Now you see this is the vector from the origin to this point. So now this is the graph of 2 plus 5i. Similarly, you can draw the graph of 5 minus 6i. Here what is the real part? 5. What is the imaginary part? Minus 6. Now you count 5 units in the real axis, that is here. So 1, 2, 3, 4, 5. Now what is imaginary part? That is minus 6. You count downwards from the origin in the imaginary axis 6 units, that is minus 6. 1, 2, 3, 4, 5, 6. So minus 6. So now this is the point of intersection. So that this is the graph of 5 minus 6i. Now similarly you can draw the graph of 3i. Now here what is the real part? 0. What is the imaginary part? 3. So what is the point representation? That is 0 comma 3, or we can say that 3i is nothing but 0 plus 3i. Now here real part is 0. So this point 3i is in the imaginary axis, because on the imaginary axis the real part is 0. The value of x is 0. So that here you count 3 units from the origin on the imaginary axis. Then you fix this point 3i here. So now this is the graph of 3i. Similarly, you can draw the graph of minus 7. Here real part is minus 7. Imaginary part is 0. Now that is here minus 7 comma 0. Or you can say that minus 7 plus 0i is nothing but minus 7. So now here imaginary part is 0. So that this point is on the real axis. So that here you count 7 units from the origin to the left. Now, so this is the graph of minus 7. Similarly, you try these 4 points. How to draw the graph of these 4 points in the organ diagram? You try. Now we'll see the absolute value of complex numbers. Absolute value is nothing but modulus of z is equal to square root of a squared plus b squared. This is the absolute value, or we can say that this is the modulus of the given complex number. Is nothing but modulus of z is equal to square of the sum of the squares of real part and imaginary part. That is the absolute value. That is the absolute value, or we can say modulus. Real part is a, imaginary part is b in this complex number. So that mod z is equal to square root of a squared plus b squared. Now find the absolute value of 3 plus 4i. How to find the absolute value of 3 plus 4i? Now here real part is 3, imaginary part is 4. So that now absolute value is square root of a squared plus b squared, that is square root of 3 squared plus 4 squared, that is root 25, that is 5, that is absolute value of 3 plus 4i. Okay, but here what is given? To find the absolute value of a complex number, find the distance from the number to the origin. Okay, now you see here what is absolute value. Graphically you see here absolute value is nothing but how much distance from the origin to the number is called absolute value. So this is called the absolute value of this complex number. Here you see in the next graph, you see here what is the absolute value of 3 plus 4i? It's nothing but absolute value of 3 plus 4i is square root of 3 square plus 4 square, that is square root of 25, 5. Okay, it is simple. You can find simply the absolute value. But how we can represent this absolute value in the complex plane, in the complex graph, that is in the organ diagram. You see here 3 plus 4i is the complex number. 3 is real part, 4 is imaginary part. So here 3 units in the real axis, 4 units in the imaginary axis. So this is the point. Now from the origin, the point is how much distance. That distance is called the modulus or absolute value of the complex number. Now you see equation of circle. This we know that already in the Cartesian coordinates. What is the equation of circle? General form of the equation of circle, that is x minus h whole square plus y minus k whole square is equal to r square. Center is h comma k and the radius is r. Now here x minus 2 whole square plus y minus 3 whole square is equal to 25, that is 5 square. This is also the equation of circle, but center is 2 comma 3 and radius is 5 units. Okay, this is the general form. This is the particular equation of circle with center 2 comma 3 and radius 5. Now you see here equation of circle with center at the origin and radius r. This is the equation of circle, the complex numbers in the complex plane. Now you see here what is the center. This is the general form of the equation of circle in complex number. Now what is the center? Z0 is the center, that is here center at the origin, that is Z0. Center is Z0, that is origin here. Okay, now radius is r, this is radius r, so that I can say z, suppose I write modulus of z minus z0 is equal to r, then what is center? Z0 is center. What is radius? R is radius, that is here given. So now we'll go back. Now you see here modulus of z minus 0 is equal to 2 is given. Now what is center? What is radius? Center is nothing but z minus what is here, that is center. So here 0, which means 0 comma 0, that is center. What is radius? That is 2. So radius is 2. Simply we can write this equation of circle as modulus of z is equal to 2, which means center is 0 comma 0, radius is 2. So here center 0 comma 0 means origin. So here this is the center for this circle and radius is 2 units. Okay, now consider this circle. Modulus of z minus of minus 1 plus 2i is equal to 3. Now here what is the center? Actually this is given. I have rewritten this equation like this. Why? Because whenever you find the center, you have to take one negative as a common factor. Now you see modulus of z minus, now here plus, but you have to take one negative outside, so that the remaining is minus 1 plus 2i. Now you see what is the real part here? Minus 1. What is the imaginary part? 2. So that what is the center? Minus 1 is the center. Minus 1 comma 2 is the center. What is the radius? 3. So that now you plot this point minus 1 comma 2. So here from this place, from this point, take 3 units radius, then make the circle. So this is the equation of circle with center minus 1 comma 2 and radius 3. Now you see here this is the general form. Suppose we write modulus of z minus z naught is equal to r. Here I put line y. Now you see here, if I put modulus of z minus z naught is equal to r, which means the points on the circumference, which means here the points on the circumference. Okay, suppose I write the same modulus of z minus z naught. Here you see the symbol greater than r, which means the points outside the circle. Here the points outside the circle. Okay, now p inside the circle, which means modulus of z minus z naught is less than r, which means the points inside the circle. Now we'll see this question. The complex number z is represented by the point p on the organ diagram. Given that modulus of z minus 1 minus I is equal to modulus of z minus 2. See here, both are circles. Now find in its simplest form the Cartesian equation of the locus of p. We have to find the Cartesian form, simplest form in Cartesian equation. Okay, now you see here, you take this equation, given complex equation is the circle. Okay, both sides circle. Okay, now you have to substitute z is equal to x plus iy. This is the general form of the complex number. So z equal to x plus iy. X is the real part, y is imaginary part. Okay, so now you substitute here for z. See, from this equation, for z you put x plus iy, then remaining minus 1 minus I, then for z substitute x plus iy. Okay, don't forget we have to put the modulus symbol. Okay, now here you have to rewrite, you have to group real part and imaginary part. Now here x minus 1 is a real part. Now you take I as a common factor, then y minus 1 is the imaginary part. Similarly you do it here. So real part, imaginary part. Now after writing the complete form of the complex number inside the modulus, you can apply the modulus condition, so that square root of real part squared plus imaginary part squared. See here, real part squared, imaginary part squared. Similarly in the right side, real part squared plus imaginary part squared. Okay, now here we have square root on both sides. So what you do, you take square on both sides, so it will be cancelled. This square root, this square, both cancelled. So the remaining is this. So now what is this? You apply the rule a minus b whole square, algebraic formula. Here a minus b whole square, here a minus b whole square. Then you do the simplification. So finally what you will get? You will get y is equal to x minus 1, which is the Cartesian equation of the given complex equation. Finally is a straight line. So now this is the final answer. When you put z equal to x plus iy in the given complex equation, you get the Cartesian equation as a straight line. Y is equal to x minus 1. Now see the another example. Modulus of z minus 2 is equal to 2 times modulus of z plus I. Now we have to show that locus of p is a circle. Now similarly you substitute z equal to x plus iy in the given equation, so that now here z is x plus iy minus 2 is equal to 2 times modulus of here z x plus iy plus I. Then you do the simplification, like means you group real part, imaginary part, and then apply the modulus condition. Then here make square on both sides, then you will get the final equation like this. Now this is called, see here, this is called the equation of circle in the Cartesian form. Actually this is the general form of the equation of circle. You have to try to change this form into this with center h and k. Now see this question. Here three complex numbers given. We have to show that these 3 points form a right angle triangle. Okay, first plot these 3 points. We know that how to plot the points. Then